Hello everyone, this is Snigdha Karkar and this is my channel AccelerateAICareers. Today we are going to solve a very interesting problem, LeetCode 46, permutations, in Python of course. This question has been asked in Meta, Amazon and Google in last 6 to 12 months for their interviews for both software developer and data scientist. Now without wasting further time, let's delve deeper into the question. So we have been given an array nums with distinct integers, so there is no duplication. And we have to return all the possible permutations. So now what is permutation? You might have come across this word in your mathematics class. So permutation is exactly any combination possible with a given number of digits, while the order of the digits can be changed. So you can return the answer in any order that is good for us. Now, for example, you have been given an example 1, 2, 3 here. So what could be the permutations? So you can have 1, 2, 3 like shown here. You can have 1, 3, 2, then 2, 1, 3 and 2, 3, 1 and 3, 1, 2 and 3, 2, 1. So a total of 6 permutations. Let's look at another example. So the other example, you have nums equal to 0, 1. So there could be 2 permutations possible, either 0, 1 or 1, 0. Now there's a third example. You have been given an array nums which has only one integer 1. And the output is a list of list. So there is only one output which is 1, but it is a list within a list. So you have to remember that you always need to return a list in a list, and hence the type of output has been given list of list. So now the question is clear. Let's dig deeper into how we are going to solve it. So let us continue with our first example 1, 2, 3 and see how many permutations are possible. So for the first space holder, you can have 3 values. Either could be 1, could be 2 or could be 3. So there are 3 values possible. Say suppose you choose any one value. So now for the second placeholder, you have remaining 2 values, 2 options. You have essentially 2. Now for the third placeholder, if you have chosen one for first, one for second placeholder, you only have one choice remaining for the third. Hence only one choice. All in all, you have 3 into 2, 6 permutations possible, since there are no duplicates allowed. Now this problem is very easy to solve by hand because it is more mathematics oriented, but the difficult part is coding it. So let's take a help of a decision tree to see what are the choices possible, how many permutations are possible and how do we get there. So for example, here in this decision tree, in the beginning we have 3 choices, 1, 2 and 3. Say suppose we go ahead with 1. In that case, you have further 2 choices, 2 and 3. If you go ahead with 2, then finally you have 3. So there is one permutation possible which is 1, 2, 3. Similarly, the other one you got was 1, 3, 2. Now say suppose you didn't choose earlier to go ahead with 1. You chose to go ahead with 2. Then in that case, you have further 2 choices, 1 and 3, right? So if say suppose you go ahead with 1. So 2, 1 and then the third choice would be 3, 2, 1, 3. The second combination here would be 2, 3, 1. Similarly, say suppose you didn't choose to go earlier with 2, but you chose to go with 3. In that case, you have further 2 choices to make. Either you go ahead with 1 or you go ahead with 2. If you choose to go ahead with 2, in that case, the combination would be 3, 2 and further 1. And the second combination would be 3, 1, 2. So all in all, you achieved 6 permutations as we deduced earlier in here that there are 6 permutations possible. And you see that you have achieved 6 permutations here. So now, but what's the algorithm? How do we code it? We know there are 6 permutations. We know those 6 permutations. But what's the code behind it? So let's look at our algorithm now. Now, say suppose when the example was given 1, 2, 3, you chose to discard this 1 in the beginning, okay? And hence you see 2, 3 here. Just look at this segment of the tree. So now when you have 2, 3, you again think of discarding the first element 2. You pop it up and you get your base case that is only one element, which is now when you have only 3 remaining. So there would be only one permutation of it, which is 3, right? So that is our base case. Now you decide to go back. So if you go back in that case, so you remember that when you came down, you got rid of this 2. So when you go back, you plug in that 2, but not in the beginning of the array, but at the end of the list. So instead of 2, 3, it will become 3, 2. So you will save that as a separate combination here, okay? Now, when you are here, you have two combinations now, 2, 3 and 3, 2. Same way, if you have chosen to go here and you popped 3 out and you came down and came to a base case 2. So when you go up, since you popped 3 out earlier, so when you go up, you plug in 3 back and your combination would be 2, 3. So essentially, finally, you will get two permutations 3, 2 and 2, 3 here. But you remember when you came from here to here, you discarded this one. So now when you go up back, you need to plug that one. So in both the combinations, you need to add that one in the end. It would be 3, 2, 1 and one combination. And the second combination would be 2, 3, 1. So you will store these two lists in your list of results, okay? So what was the algorithm again? We are doing it by recursion, kind of backtracking. And whenever we take a step ahead, we pop the first value. When we pop the first value, we decide to go ahead further. We again pop the first value. And then we take one step back and we append it to the end. Whatever value we popped earlier, we append it to the end after getting the combinations. So now we have the combinations. We have 3, 2 and 2, 3. We further go back and the value which we had popped, we append it to the end and we get 3, 2, 1 and 2, 3, 1. Similar way, here when you have 1, 3, you actually popped out 2, okay? So when you popped out 2, you have to remember that you popped out 2. Here 1, 3, you decide to pop out 1 and you go to base case 3. So all permutations of 3 would be just 1, 3. So you go back and you had gotten rid of 1 here. So you append 1 to the end of 3. So essentially you will get another combination here which would be 3, 1. So 1, 3 and 3, 1 will be two permutations. But you remember when you came from here to here, you got rid of this 2. So you have to append that 2 also in the end. Hence, your two combinations would be 3, 1, 2 and 1, 3, 2. I hope this is clear. So now in the third case, you got rid of this 3. So you have 1, 2 remaining, right? Now, when you go down, you think of getting rid of this 1 and hence 2, the base case. So now any permutation of 2 would be just 2, right? You go back and you had gotten rid of 1 here. So you append it back. So the other combination you would have would be 2, 1. Now you have two combinations 2, 1 and 1, 2. And when you further go back, you remember that you got rid of 3 here. So you have to append that in the end. So the value would be 1, 2, 3, 2, 1, 3. So these are your 6 combinations. I know this is difficult to understand for now, but when we start coding, you will get a knack of it. Remember, the approach we are using is recursion backtracking because we are following the same step. We are popping up one integer out of the list and then going ahead with all the permutations possible of the remaining list. And then we are appending the popped up integer at the back to get the permutations. So let's go ahead and start coding. First of all, we'll initialize our result variable with an empty list. Now, what would be our base case? So our base case would be if the length of nums is just 1. So if length of is equal to 1. What would you return in that case? In that case, you just need to return nums, all the values, in a list, of course. So since it needs to be returned in a list, you enclose it within a list, okay? So that is your base case. Now, we'll run a loop through the entire array. So for I in range, length of nums, okay? Here, we pop up the first variable and we are storing it in a variable n because we are going to use it to append it later on, and hence I'm saving it. And then we get all the permutations of the remaining. So self.permute. Since it's recursion, I'm calling the permutation function again, and I'm following the same steps basically here, and I'm storing all the permutations in variable perms. For perm in perms, in Python, we have append function to append the variable to the very end. So when you have all the permutations, then you can append n to the end. So this is done. Now we need to save all these permutations, finally what we have obtained in our result list. So if there are more than one permutations, so we have another function in Python extend where you can append more than one results. So we will just extend result.extend perms. And then we need to do the cleanup. Since we initially popped one value from nums, we need to add it back before going ahead for further permutations. So nums.append n. So the cleanup of the list has been done. The list looks like the same list it was before. And finally, we return the result. So let me walk you through what we did again, just a summary. We initialized our result list. After that, we defined our base case. The base case would be when the length of nums is 1. In that case, you just return all the values in the nums in a list, within a list, okay? That's what you are doing. Then you run your index I in the range of length of nums, that is, you run across the entire loop and you pop up one value from the nums. So essentially you are popping with the first index value and saving it in a variable n. And then you are getting the remaining lists permutations using recursion. That's what you are doing here. And you are saving all the permutations in perms. Then for each permutation in perms, you are appending the n which you popped earlier, like we did in our example when we were demonstrating. So finally you have the permutations and they are in perms. So finally you extend your result list and add all those permutations there. Now you have the permutations in your result list. You have to go to the next index. Before doing that, you have to clean up your array. Since you had popped one integer before, you need to add that again. So you append it to the end. And then finally you run out of the loop and you return the result. So let's see if this works. I made a minor mistake here in the code. So when I'm popping, I need to add 0 here because I'm popping just one value from the 0th index. Now let's run. Let's submit. So as you can see, it performs quite well. If you have some other approach to solve this question, do let me know. I would love to learn from you. If there is a specific question you want me to prefer or solve first, mention in the comments here. If you like my way of solving problems, subscribe to my channel, share it with your network. It will help me and encourage me to make more videos on LeetCode. Thank you.